spend some extra time in sorting the elements. Okay, now we want a search method which takes just constant time. So from n we have moved to log n, and from log n we want to move on to order of 1. So this is the requirement which introduces hashing technique. So let us see hashing. In hashing technique, if a list of elements are given and an array space is given where we have to store the list of elements, then we store the element upon its own index. We take the value of an element itself as the index and we store it at same index. So 8 is stored at 8, and 3 it is made as index and it is stored at location 3, so on. Now when we want to search for any key element, let us say 10, then we directly go to index 10 and see if the element is present or not. If we want to search for key element 12, then we directly go to index 12 and see element is present or not. So 12 is not found. So the search time is order of 1. Directly we have to go to that index and look for the element. But the problem is, if I have one more element, that is 50, then we have to store it at index 50, which may be far away. So here for storing this 50, we should have an index 50 in the array. So a lot of space is wasted in this method. If we want to reduce the time, then we may have to waste a lot of memory. Just for few elements we need a very large size array where most of the spaces are vacant. To improve this technique, or to improve this basic idea, we adopt a mathematical model. We design a mathematical model for hashing based on functions. So let us see next how it is modeled using mathematically. The list of elements what we have, we call them as key space, and the place where we have to store them, we call it as hash table. And we say that there is some function, say h of x equal to x, which is mapping these elements from key space to hash table. So h of 8 is 8, so this 8 will be stored at index 8, and same way 3 is stored at 3. 13, h of 13 is 13, so it is stored at 13, index 13. So we say that h of x equal to x is a hash function which is mapping these key elements from key space to hash table, and this we take it as an ideal hash function. So this is the same case we have seen just now, and we have just made it in the mathematical form. Now in this, if I have an index 50, then I should have a, if I have a key element 50, then I should have an index 50 in the array. So I should have a very lengthy hash table. Again, the problem is same, that a lot of space is wasted. So if we see the properties of functions, there are two types of functions: one-to-one function and many-to-one function. These are the two type of cardinalities followed by functions, and h of x equal to x is a one-to-one function. If we take any other function other than h of x equal to x, it may be many-to-one function, but also it depends on the keys or the hash table size. So but mostly it will be many-to-one function. Now we say that here this function is responsible for mapping the elements to their indices. So we should modify the function to efficiently utilize the space in hash table. So we will try to modify the function. So here we take hash function h of x equal to x mod. This is the size of hash table. Ten is the size of the hash table. So now we will take a hash table size as 10. As an example, I am taking the size as 10 here. Size can be, we can take a hash table of any size. So hash function, I am taking it as h of x equal to x mod size, and the size is 10. Now Let us map the elements. 8. 8 mod 10 gives me 8. So 8 is stored here. 3 mod 10 is 3. So it is stored here. 13 mod 10 is also 3. So, oh, this is a collision. So this is causing collision. Now the problem is when you change the hash function, then there is a possibility that two or more elements are mapped at the same index, and that is called as collision. Now we have to resolve this collision. We have to solve this problem. There are different methods for avoiding collision. For avoiding collision or for removing collision, we have different methods, that is open hashing, under that is chaining, and next is close hashing, under that we have linear probing and quadratic probing. Let us look at them one by one. First method for resolving collision is chaining. In this method, when we map any key using same hash function is same. When we map it, it will be mapped at 8. So we'll not store the element in the hash table itself, but at this index we will add a new chain, and in that we will insert the element. Chain is nothing but a linked list. 3 is mapped here, so we will add a node to a chain and insert 3. 13 is also mapped here, so we'll add a new node, and there we will